Hello, everyone, and welcome to our webinar. My name is Johanna Manso, and I am the Logistics and Event Manager for Internet Systems Consortium, and I will be your host for today. The title of our presentation today is Secondary Name Service, SNS at ISC, and our presenter is Peter Losher, Senior Operations Architect. Several quick points. This webinar will run for approximately 25 minutes before we go into Q&A. All webinar participants are automatically muted upon entry. This webinar is being recorded and will be posted on our website within 3 business days. If you have questions about WebEx logistics, please forward them to me by typing it into the chat area. We will have several pauses during the presentation to answer questions from attendees. To submit a question about the content of this webinar, you have 2 options. Option 1, you can type the question into the Q&A area in the bottom right-hand corner of your screen. When the time comes, I will read it out to our presenter. Option 2, you can click on the Raise Hand button or the Request button. At the appropriate time, I will unmute your microphone for you to ask your question. For those of you that are not familiar with us at ISC, we are a non-profit public benefit organization, and we handle software, services, and operations for core internet infrastructure. Here's an overview of what we do at ISC. Now, without further delay, I would like to hand over the mic to Peter. Go ahead, Peter.
Thanks, Johanna. Hello, everyone. My name is Peter Losher, Senior Operations Architect here at Internet Systems Consortium. Thank you all for coming to this ISC webinar about our newest offering, SNS at ISC. This will be a 25-minute presentation with background and a quick demo of the actual webinar phase. We will cover how, number 1, DNS as critical infrastructure, number 2, what is SNS at ISC and how it works, number 3, what is Cloud or AnyCAT DNS, number 4, SNS at ISC's feature set, number 5, ISC's experience, number 6, a walkthrough or a tour of the SNS webinar phase, and last but not least, a Q&A. But first, I want to start with DNS as critical internet infrastructure. DNS is the mechanism that gives you the ability to type into your web browser a human-readable string, such as www.isc.org, instead of a string of IP addresses, like 127.0.0.1 or : 1. DNS is what helps power the internet. Every hostname you type in, every email that you send, every update you make on a social networking site all use DNS. DNS is what helps power online businesses. Every order you make online at an auction house or department store uses DNS, or even to transfer money between bank accounts, or to pay a friend back for your share of last night's dinner uses DNS for part of that transaction. DNS is also what helps power mobile applications. Any application that you use on your mobile device that updates over Wi-Fi or 3G uses DNS to pull down any updates. Whether it's from a social media application to email or to update the application itself through some sort of app store, it's using DNS to help locate and make that connection. In the end, DNS is critical to you and your business. So, with that being said, there are issues confronting businesses in building a robust DNS service. In terms of scaling and redundancy, you want to make sure that your infrastructure is able to handle the growth of your business needs. Are you a small business that has just a handful of DNS lookups? Or are you an enterprise that handles thousands of DNS queries a second? You also need to make sure that your infrastructure is resilient and redundant in light of any component or environmental failures. Long are the days when you could just have a server in a corner serving DNS for your office and for your online brand or presence. You also need global coverage. The Internet is global, and so should you. To provide better performance and resiliency, you should be able to serve your DNS data from multiple points around the globe. So a client in Europe should be able to get an answer in Europe. A customer in Asia should get an answer in Asia, and not have to send that traffic back to the US, and so on. This can save critical seconds when loading a web page or making an online transaction. Also want to handle online threats, because let's face it, the Internet is all not roses and rainbows. Denial of service attacks are a real issue, and protecting DNS is a critical part of protecting your online brand. So what is SNS at ISC? SNS at ISC is a cloud DNS service designed to make sure that your customers can find your network and connect to it. It will enhance your customers' experience by optimizing their access to your online content when it matters most, enhancing your network's brand name and revenue. ISC has utilized well-tested and proven technologies to build a robust DNS infrastructure to handle enterprises big and small. So, who is SNS at ISC for? For businesses and organizations that operate their own DNS infrastructure that need a cost-effective way to publish their DNS data on a global DNS platform. Here's one example. We have a customer that operated redundant DNS servers in 2 regions of the US, but had a global customer base, so wanted to have servers serving their zones worldwide closer to their customers. Now, they could have built their own infrastructure, getting co-location at various points around the globe, buying servers and network connectivity, and run the servers themselves. Instead, they purchased SNS at ISC service and instantly had their DNS data replicated at over 14 locations worldwide. SNS at ISC is for businesses and organizations that need additional resiliency in their DNS infrastructure, either standalone or as part of a wider resiliency design. Customers may have a model where they use SNS at ISC name servers exclusively for all external DNS queries, or they may pair us with their own existing DNS servers to add resiliency to what they have now. We may even have some customers who add us in as another cloud, as they may already have another or multiple DNS providers already in the mix, but that tends to be an extreme case. So, what is Cloud DNS? Or the more technical term tends to be, what's AnyCAT? The dictionary answer for AnyCAT is that it's a network addressing and routing methodology in which servers from a single sender are routed to the nearest node in a group of potential receivers, all identified by the same destination address. This is a one-to-one of many associations that you can see in the diagram in the next slide. So, to try to explain this, I've got this slide here. Now, in a traditional UniCAT setup, the IP address of the DNS server, say in this case 10.0.0.1, would go to one server location. Now, it could be in the US, it could be in Europe, it could be in Asia, but it's a single server. It's a one-to-one connection. Now, in an AnyCAT setup, you would have multiple servers advertise the DNS service address. Again, in this case, the IP address could be 10.0.0.1. Now, it would be advertised on multiple points in the network, and traffic would be routed to the closest server advertising that service address. So, if you have a server located in Europe, most of the traffic from Europe would hit that server, and in Asia, the Asia-based server. Now, if for some reason that server goes away because of maintenance or some other issue, traffic would just flow to the next closest server serving that same service address. All in the background, you wouldn't notice any change other than perhaps a slight difference in performance. Now, AnyCAT provides us the flexibility to have multiple servers at multiple locations so that there is just not one server at that address, but multiple, which helps us as a DNS provider with things like traffic shaping and DDoS prevention. So when you see an IP address, it's just not a single IP address to a single server. It's a single IP address that has maybe one server, 2 servers, 3 servers, 5, or maybe a dozen. This technology is not new. AnyCAT has been used in DNS service offerings for over a decade and is a well-tested technology used by many DNS service providers, including ISC. So how does SNS at ISC use AnyCAT? ISC is partnered with 3 global backbone providers. They include Tata Communications, Cogent Communications, and Hurricane Electric. In addition, ISC has nodes located at multiple locations inside those networks near major interconnection and exchange points. Our design is that we operate per provider clouds, so all of the nodes in one provider is one cloud, another node with another network with all those nodes is another cloud, and so on. Locations inside those networks include at least an east to west node in North America, as well as a node in Europe and Eurasia. With our partners' aggressive private and/or public peering, most traffic stays in region, keeping response time short. So in this slide, we have a map showcasing our locations. With the initial rollout that we're announcing today, we're focused on the major interconnection points globally. We are looking into expanding our footprint, and new sites will be based on customer feedback and interest. For example, if there was a lot of interest in Africa, where that traffic currently goes to Europe, we would look at adding the node in the region, like, say, in South Africa. But we are currently focusing on maximizing our service in the areas that we are currently serving. At several of these metro locations, we may have multiple nodes in the area, but they are usually in different data centers, except for one where we have 2 at the same site, but they're on separate clouds or separate networks. At this point, I would like to pause and see if there are any questions at this time.
Peter? Oh, okay, hold on, this one. Okay, this one. Has the SNS at ISC infrastructure been tested against cyber attacks? Are there any cases?
Considering that we're currently launching the service today, we haven't had any sort of large-scale DDoS attacks against the infrastructure, but the infrastructure has been built based on experiences that we've had operating DNS services, things like one of the 13 root servers, and those servers, or that infrastructure, has been under attack and it's been documented over the last 10 years. So a lot of the things that we have learned from those experiences we built into SNS at ISC.
Okay, thank you. Okay, I see. I see one more. Where can I find the list of nodes?
We currently don't publish those locations specifically. Basically, where we're currently at is Singapore and Hong Kong in Asia. We're at Paris and Amsterdam with several nodes, also in Frankfurt in Europe. We have San Jose and LA with several nodes, and Montreal and the Washington, D.C. area with a couple of nodes. So multiple nodes inside those locations. So we currently have about 14 locations right now.
Okay, good. Okay, let's take on one more question before we continue. This is there something to gain by using multiple AnyCAT providers?
The gain is basically that you have additional resiliency because you have different network points. You have, even though the servers are basically operated by ISC, we all have different, or the networks all have different arrangements for their peering. So you may see better performance from one cloud to your customer base versus another cloud. It just depends on where your customer base is and how they match up to the actual network providers. So we usually say that having 3 providers also allows you for additional resiliency. So if we have a problem with one provider, all the traffic will just flip to one of the other clouds. So there's one is based on performance and another is based on resiliency.
Okay, good. Okay, I think we can go ahead and proceed.
Okay. So now we'll go into the SNS ISC feature list. So first point is that it's built using ISC bind 9 DNS software. Now, we don't really back down on this point. We know there are other vendors in this field that use bind as a vulnerability based on outdated information. Like, oh, bind has the number one most vulnerable software based on exploits and vulnerabilities. Well, a lot of that was based on bind 8, which was deprecated over a decade ago. Bind is by far the leader of both feature set and usability, and over 2/3 of deployed DNS servers use bind, and we're proud to use it on SNS at ISC. Now, one advantage is that at ISC we do have direct access to the bind development team, and they're here to help address any issues that may crop up. And you may find that something that we end up finding out with SNS at ISC is something that basically then goes into the actual community code base, and that optimization or bug fix will be used by the community at large, even our competitors. So, so by helping us, it also does help the community. SNS at ISC fully supports both IPv4 and IPv6. Both the back-end and the external-facing DNS clouds both support IPv4 and IPv6. Currently, to be fair, 2 of the 3 clouds are fully dual-stack. The third is in progress, and we're working with them to see when their IPv6 reachability meets our standards before we actually turn it on, because we don't want to turn it on and find a third of the IPv6 internet can't reach the node. That wouldn't work. We also support DNS security extensions, or what's more commonly called DNSSEC. For those that don't know, DNSSEC is a set of extensions to the DNS protocol so that every answer that a DNS server gives can have a signature that can then be validated as coming from the authorized source. So if I'm going www.isc.org, I can give what's called a signature associated with the answer that you can validate that says, this answer is actually valid and comes from ISC. If you already assign your DNS zones using DNSSEC, then they will be fully supported by SNS at ISC. And we had this come up at one of the previous webinars. We actually do not charge extra for the fact that your zones are signed, and because they're bigger or they may add computational load to serving the data. We charge it the same whether it's signed or unsigned, and you do not pay extra for the fact your zones are signed. We also offer service level agreements, or SLAs. We offer a contractual SLA on uptime based on how many of the SNS at ISC clouds you implement, whether it's 1 or 2 or 3. If you use 3, it's up to 99.9999 uptime. We also allow account management via a web UI interface. This will allow you to set up the servers you want us to pull your DNS zone data from, set up TCP keys for those source servers, the list of zones you want us to serve on your behalf, and so much more. Later, I'll present a demo of the web UI so you can get a feeling of it yourself. Now, for those of you that have 20 or more zones that may change often, you may be interested in our bulk API option, where you send us a list of DNS zones, we check that they're yours, and then add them into your account. One of the other things we're actually very excited about is the collaboration with a technology called Passive DNS. Passive DNS from ISC's Resiliency and Security Forum, or RSF, is used as an external check on response times from various caching resolvers around the world. Currently, most of those resolvers are in the US and Europe, and we're currently working trying to add more sensors in Asia. We make all that data available to all SNS customers as a check on the health of the SNS ISC platform. You can read more about Passive DNS at rsf.isc.org. Now, continuing with the feature list. Per zone statistics. SNS at ISC has the ability to show you, in pretty much near less than 15 minutes ago, real-time stats including query load, which region the traffic is coming from, like East or West Coast US, Europe, and Asia, and the ability to zoom in to get into more detail, as well as looking at any historical data from the time you started on SNS at ISC. We also support transaction signatures, or what's more commonly called TSIG keys. TSIG uses shared secret keys and one-way hashing algorithms to provide a cryptographically secure means of identifying each side of a connection as being allowed to perform a DNS update. We use this as an additional layer of security to validate that we are getting an update from a valid master server that you have configured. Also, because we're using Bind, we fully support AXFR and IXFR zone transfers. Now, we support AXFR for full zone updates, as well as IXFR for incremental zone updates. For zones that are large and that can change often, we prefer to use IXFR, which only transfers the differences between the old and the new zone file, which speeds up the zone update process for larger zones, because we try to target an update to handle at worst between 3 to 5 minutes after we are notified that the new zone is available. Most of the time, it actually happens much quicker than that. We also offer serial number checks. SNS ISC will continually check to make sure it has the latest zone as listed on the source server, and if not, it will alert the customer so he and she can investigate. Alerts such as may crop up if for some reason you firewall the source server so we can't contact it, or the server is now giving out a refused error because you got into the server and all of a sudden you removed us from your ACL so we can't transfer the zone. Now, you can find out this information by looking at our activity logs. We give you the ability to see the activity logs so you can investigate any issues you may find in zone updates, or to validate that we are updating any new zones as fast as we can. So you can look and see, hey, I saw the notify come from my source server at X time, and saw that it was propagated across all the SNS servers within a minute. Now, last but not least, something that we're really excited about is our threshold monitoring and notification system. Via the SNS ISC web interface, you can set a minimum and maximum query per second number and get alerted if traffic exceeds or drops below the preset figures. There's also a smart detection threshold that does almost the exact same thing, but it does it based on a rolling average. This is used as an early warning detection to make customers aware of any unusual DNS traffic or activity. So, with all that said, what does ISC bring to the DNS services market? For those that haven't known us for very long, or think all ISC does is software, like Bind and DHCP, note that ISC has actually been in the DNS services arena for as long as ISC has been around. The previous incarnation of SNS at ISC served many nonprofit organizations and 30-plus CCTLDs, such as .fr in France or .nl in Netherlands, to the smaller CCTLDs like .pn, Pitcairn Islands, and AQ is in Antarctica. Yes, they actually have their own TLD. ISC has also been operating f.rootservers.net, one of the 13 DNS root servers, for 18-plus years now. About a decade ago, we started AnyCATing the service ourselves, and now we are at almost 60 locations worldwide with the service. And you can see a map of the locations in the next slide. Now, I should mention that you see this little dot in the middle of the Pacific Ocean. That is actually a node. It's actually in Fiji, but Fiji is so small it doesn't actually show up on the map. So, but you can see we have about 60 locations worldwide. We have locations in such diverse places as San Jose, California, Ottawa, Canada, Quito, Ecuador, Sao Paulo, Brazil, Dar es Salaam, Tanzania, Brisbane, Australia, Ulaanbaatar, Mongolia, Moscow, Russia, and many, many, many other locations. So, in conclusion, DNS is a critical part of the Internet. To protect your DNS infrastructure, protects your brand and online presence. SNS at ISC is a cost-effective way to get your DNS zone data published globally, which improves resiliency and performance. And ISC is a trusted partner in the DNS services field. Contact us for more information on how we can help you. Now, at this point, if there are any other questions before we start the demo.
Yes, we have a question. So the question is, you're describing the SLA in terms of availability. What about performance? What level of performance can I expect, say, in queries per second or traffic?
Well, first of all, it depends where the customer is. Obviously, if you're a customer in Africa and you're querying us, you're going to get us in Europe. So you're going to get a response time that's probably in the anywhere from 80 milliseconds to 150 milliseconds or higher, just depending on where you are in the location. If you're somewhere in Europe, we tend to average, and you'll see this with the passive DNS graph, is that we tend to average on the low end about low 20s, 20 milliseconds, up to around 35 or 40 milliseconds. As I said, that depends on where you are in the region, as well as sort of your network connectivity. If you have to have more than like 10 or 20 hops to get to us. But as I'll show in the demo, that's what we normally average in performance. Some places are quicker, some places are further away, so the performance will change depending on where you are in the location. So if it's a case of you currently have a DNS server, say in Chicago, but you find that your customer is in Hong Kong, so right now all that DNS traffic has to go across the Pacific to Chicago to get a response back, and so the response may be 150, 200 milliseconds because it has to cross over that ocean. Now, if you have SNS ISC, we have a local copy of your zone in our node in Hong Kong. The response time could be probably as low as about 20 to 30 milliseconds. So you're shaving about over 150 milliseconds, or a couple of seconds at least, in just response time.
Okay, good. Thank you, Peter. Okay, next question. We have external websites and virtual servers that we would not want to lose the ability to have our customers reach in the event of a disaster in our building. Is there a way to do that with SNS ISC as a backup DNS name server?
I would say in that scenario, if it's a case of customers or getting external access, so say if you're running a virtual farm or virtual server farm and you're trying to get customers who have to access those servers, whether it's via the web or via SSH, having DNS handled outside that area is a good way to add resiliency, because obviously you don't want to have your eggs all in one basket. So having SNS ISC will provide you an additional connectivity to say, hey, look at these servers, they're at 10.0.0.3, and then you can go ahead and try to make the connection. Now, hopefully the virtual servers are in a location where they have power and have connectivity, and perhaps are on a separate network segment or power segment from, say, your DNS servers. So in case of some sort of power outage and so forth, we can give you the address, but if you still can't make the connection, there's nothing we can do after that. So yes, having SNS at ISC adds you more resiliency, because we can serve your DNS data from multiple locations around the globe, so we're not tied to a particular site.
Thank you, Peter. Okay, let's take one more question before we go to the demo. Okay, from David, how quickly can a new customer be deployed? Suppose I sign up today, can my zone be set up in a couple of days?
Yes, should be shorter than that. So as you'll see in the web demo, it's a very quick process.
Okay, thank you, Peter. I think we can proceed now.
Okay, let me go ahead and share a couple of applications here. More. Okay, so here's the SNS ISC web interface. I'm using the demo account. And because I'm using a demo account, there's no actual data. But this will give you a good understanding of the web interface and how easy it is to actually set up a zone. So first off, we have TSIG keys. So those are the transaction signatures. So you just add a TSIG key. So we always use the strongest algorithm possible. Now, a lot of DNS servers still just allow HMAC MD5. We go two levels above that. There are some that only support HMAC SHA-256, so we allow for that backward compatibility. But wherever possible, most modern or all modern bind releases, and I think the latest NSD and Power DNS and other software packages do support HMAC SHA-512. So basically select that, click Create. We create a TSIG key with a unique name and with a key, which if you click on Show and Hide, for those of you that run DNS servers that aren't bind, you can just take the full key and cut and paste that key into your config and run with it. If you're running bind, we give you the whole stanza in bind syntax form, so you can just cut or copy and paste that directly into your named config and go ahead and run with it. Now, with that TSIG key, just set up a source server. So this is the server we're going to be pulling your zone data from. So let's try 204. Now, I can't stick a RFC 1918 address because we don't allow that for obvious reasons. So I'll stick address here. Test server. And we give you a priority, high, medium, or low. This is in case you have multiple source servers and you want to give one precedence over the other. You can do that based on the priority. And using the TSIG key that I just created, and click on Save. So there you go, all set up there. So now that you have a source server, you say, which cloud do I want to be advertised on? We have three, obviously, as I said earlier. They're easily enabled or disabled with a click of the button. Now, we may have customers who may only want to be on one cloud, or maybe they only want to be on clouds that are both dual stack, because I said only 2 of the 3 are currently in production as dual stack. We prefer that everyone uses all 3 clouds because it provides the maximum redundancy and resiliency, but people may have a reason why they only want one because they're using us in the mix with other DNS providers and they only have one IP address to stick in, or one set of IP addresses to stick in. So depending on your preferences, you can enable or disable, and within a couple of minutes it'll update the configuration across all of our servers. So for a list of zones, just add new zone. So SNS test and save. And so it's already added, and you can edit it and that's how you can delete it. You can also check it. Currently, we have no publication servers because I disabled them all, but we also have the source server that will, if it was actually serving that zone, it would give you a serial number and when it was last checked, and then you could check it across all the publication servers for the zone. And it gives you a quick way to actually see what the current serial number is, as well as when we last checked it. We usually check every 5 minutes. Now, here's the stats. Currently, this is blank. I will show you in another screen shortly what it looks like when you actually have live data. But but you can select on a per zone basis or not. So I'll come back to that in a moment. Now, under stability is the passive DNS graphs I was showing earlier. Now, as I said, we currently have only sensors in Europe as well as the US, and obviously the numbers are dependent on where these sensors are, but we can give you the graphs where they're hourly, daily, weekly, and so forth. And so we put them up here. It's aggregate, so it's not per customer. It's just aggregate across across all of our zones, whether it's you in particular or all of our customers. So this gives you a check to say how well we're performing. If all of a sudden the graphs all go up, then it looks like there might be an issue on our end or a network disruption. So it's a good way to keep us honest, so to speak. So as you see, we've got one down in the 10 range, and that is in Germany, likely because it's hitting our node in Frankfurt. So we also have the traffic alerts. As I said before, we have smart detection, which basically just keeps a rolling snapshot of time. So if your traffic graphs tend to be rather flat or keeps that very steady, and all of a sudden you see a spike, that will trigger, if you have this enabled, it'll trigger a email that says, hey, you should probably look at this. Or if you have a custom threshold where you want to set a number for queries per second below, if all of a sudden you see your queries go down, it may be because you have a truncated file, or someone made a change in your infrastructure that shouldn't have been made, and all of a sudden you're getting a lot fewer queries. So that's one reason people want a lower threshold, as well as the above threshold, which is obviously if I see a whole surge of DNS queries, either I'm under attack or we had a marketing campaign for this new domain, which is really, really successful. So we give you the ability to sort of say, set your own thresholds, as well as just have a rolling monitor. And once those thresholds are met, we send an email, and we also list it in the recent events entries. So if you see a persistent hitting of a threshold, it helps you in determining whether or not this is anything malicious, or it correlates to an event that's happened on your network. So event logs. So show, yes, the zone that doesn't exist. So basically, this is us trying to pull the zones from a non-existent server, but it gives you an understanding of what it looks like. If you have a lot of zones, you can do it on a per zone basis or all zones, and you can also download. So in case you want to use your Unix tools or so forth to grep the file and so forth, we do just give you the file in plain text that you can just download. So let's flip over to the stats. So this is a customer who generates at peak about 125,000 queries a second. And so you can see this is just a little Ajax app, and as you can see, if you point at a particular point in time, it will give you the date as well as the queries per second at that particular moment. This particular customer, they do a lot of reverse zones. So a lot of the traffic that they get back is actually referral errors or referral responses. So I'm looking for the reverse of 10.0.0.1. I don't give you any PTRs, but I'll give you, hey, look at this name server instead, and that's called a referral. So if you're an enterprise zone, you'll probably see more success, so more green versus the light blue. But we do the major types. We're currently looking at possibly adding, perhaps later this year, an ability to basically whittle it down by resource record type. So how many A records, how many MX records, because sometimes attacks may come in the form of, we're just going to throw one type of DNS query added, which is easy to highlight. Now, this work was made possible by the XML stats engine that's currently in bind that collects all this data, and then we collect that data and visualize it into the graphs you see below. So I can take here and hold the button down and drag across and say I want to focus on this particular period and say, this is interesting. What does this spike represent? And see if it correlates with anything that happened basically on our corporate infrastructure, and see if that was caused by some event or some such. You can also zoom back out, do it per hour or daily or weekly. Obviously, weekly means we have to pull a lot more data, so it has to sit there in the background and churn while it collects all that data and visualizes it, as well as like see February 27th to March 12th, and you can change this. Let's move this back to say daily. You can do it on a per region basis. So hey, I want to see all traffic in say Asia. So click that. We'll go through and change that. So instead of 125,000 queries, it's actually peaking out at about just slightly above 600. As well as you can select the date. So say I want to go from Sunday to Monday, and I'm just keeping the range short, so it'll be pretty quick in its response. That actually shouldn't look like that. But let's flip it back to all the nodes with 5 minutes. Oh, that's why. Let's move this. Yeah, there we go. So to a 5-minute span, that looks a little bit more normal, and you can see over the course of, say, 2 days. So that's basically it for the demo. So I'll hand it back to Johanna for some final comments and before the Q&A. Johanna?
Thank you, Peter, for that wonderful presentation and demo. In a second, let me get the ball back. Okay, good. So we'll be starting our Q&A session soon, but before we do that, I'd like to mention a few other things. IC also offers events and trainings around the world, and here's a list of our upcoming sessions. Our next webinar is actually next week, next Wednesday, and it's going to be our in Spanish version. And we also have a training session in Arlington, Virginia. We have another webinar coming up, another training session in Virginia, and also a training session in UK. So please visit our website, www.ic.org, for more information. Now, we'd like to mention some ways that you can keep in touch with us. If you have an SNS-specific question, please email them to us at sns@ic.org. If you have questions about IC or any other products or services, please email them to us at inbounds@ic.org. We are also on Facebook, LinkedIn, and Twitter, so we invite you to connect with us there as well. So last year, IC created our knowledge-based website where we post articles and how-tos. You can visit us at deepthought@ic.org to read these articles, or you can also contribute new articles. We truly do welcome your participation, so please do visit us and contribute. Last but not least, here's the website for SNS@ISC, and that you can visit for more information on today's topic. So let's go to questions now. Okay, so I have a question. When my zone are subjected to a DOS, what kind of help can I expect from ISC?
So in the case of DDoS, you would contact our customer support and basically let us know if we haven't already detected it ourselves. We would try to diagnose the actual traffic and try to mitigate it, working with our network partners to try to block the traffic upstream. And we will also work with you to say, is this a new domain? Is this being used for any unusual activity, like say, if it's a gambling site or something like that, which may cause say activity and so forth. So it's something where we would work with you as well as with our network partners to try to mitigate the traffic wherever possible. Now, it also depends how big the spike is. If you normally get 500, say, 500 queries per second, and it jumps up to, say, 3,500 queries per second, we don't necessarily consider that DDoS. If it was, say, instead of that, it jumped to, say, 30,000 or 50,000 or 100,000, then obviously that would be a different matter entirely. But so it depends on the situation always, and obviously I can't describe in detail what we'd actually do, but we try to analyze it as well as work with you and our network partners to try to mitigate the traffic if we know it's coming from a certain location or something like that. So we do also have mitigation technologies on the servers and infrastructure to try to traffic manage. So if we're getting like a whole bunch of traffic from one IP address, that will get blocked relatively easily and automatically. We do have mitigation strategies both on the server level as well as the network level.
Thank you, Peter. Okay, I'm not seeing any more questions. I'll give people a few more minutes to type them in. So while waiting, I just wanted to remind everyone that our webinars are always free and that we run them 3 times a day Pacific time, 8 a.m., 1 p.m., and 7 p.m. as a public benefit service to our worldwide constituents. So please help us to spread the word by informing your coworkers and anyone that you think may benefit from this webinar. So let me go ahead and check one last time. Okay, Peter, I think let's wrap it up. Do you have any last words?
Thanks, everyone, for your time, and hope this was educational for you. And if you have any questions about the service, technical or otherwise, please let us know.
Thank you, everyone, for attending. Goodbye.